and welcome to this lecture. So in the previous lecture we have just implemented this long method, and that was basically checking the Mario for our Y coin box collision. So now we have to implement our adjust Mario, and it should be Y brick collision. So let's implement that. Firstly, I'll just copy it, this Y brick collision, and just paste it out here after this, and just define it as a function, and we just pass here self and brick, because now the collider will be brick. So this function basically checks the Mario collision with the bricks on our y-axis. So for that we want to make use of this Mario and get the rect. That is, in order to get this y component of our Mario, we have to use this rect. If you have here written x, and that would be wrong because we are dealing with the y-axis, so here should be y. So if it is greater than our brick, that is our brick dot rect, and in order to get y we also use this rect position, which is basically creating the rectangle out of this brick image or sprite, so as to say. So we'll just check now if brick is state. So similar to that of coin, we have now if the brick is state here, if our brick state is resting, so this will be, most of the time this will be true. And now it's time to check, that is, if our Mario is bigger or not. That is self.mario.big. so this will check if our Mario is bigger or not. That means it will just pass true if it is bigger, false if it is not. And it should not be or, it should be and the next statement here is if the brick content, that is if brick content is none. So if the brick content is none, so there is nothing in the brick, there is nothing means if it hasn't basically mushroom or anything like fire flowers, this means the brick content is none. In that case, what you're gonna do is we'll just make here a new function, that is check if enemy is on brick. So this is the new function basically which should be implemented, and this is important function because in this case when the Mario has a strike on this brick and the brick content is none, so there is highly chance of having an enemy in that brick. So this will be handled by this check enemy on brick. So this not be in enemy, it should be on brick. So this function should be implemented and just pass here a brick, that is basically our collider. So just pass here a brick. And next thing is you want this brick to be killed. That means just remove this brick out of my gameplay. That should be calling this kill function. And next thing what you're gonna do here is we have to now deal with this check if enemy on the brick. So before that I want to just go here in this if the content is none part, and I'll just check else if it has any content. So that means we have to just increase the score. So basically I'll check if our brick and coin total, if our brick contains any coin, that means if our brick contains any coin, then what are you gonna do if it is greater than 0. Basically if it is greater than 0, then what you're gonna do here is we want to add this coin to our coin total, and we'll also add coin score. So when you get one coin, the score increment was 200, so we'll just implement that in here. So firstly we'll just add this coin in our coin total, that is in this game info dictionary you have, that is key as coin total, and in this coin total just add 1 because we have just found a coin in that brick. And we also have to add the score to our game score, that is calling here as an score, and just add here 200 because with one coin you have to have your score as 200. So next thing we'll also check here, that is basically after this if the coin total is basically greater than 0, you'll have this score. Else something, that is we also can have here basically our enemy. So check if enemy on brick. So this function should be called again and just pass here a brick. And the next thing what you're gonna do is we'll just bump that brick. So start bumping function. Start, we have bump. So let me just put here dot, because this is our brick class. So start bumping. So in this start bumping, what you're gonna do is we'll just pass here moving score list. So we'll say moving score list. So this will be the next statement, and here maybe outside this resting, let me say it should be in after the resting maybe. So it should be here, and if it is none, and that should be checking the enemy. And if the brick is dead now, so it should be quite here maybe. So what if we have our brick state that is not resting but it is opened? So what if it is opened? So let's implement that. So what if it is opened? What are you going to do here? First thing, we'll just basically do nothing here. Basically just pass. You'll do nothing here because it is open, so you'll not find anything there. And next thing what you're gonna do here, that is if this is basically rect is greater than y, then you have to increase our Mario velocity. That is here the weight of our rect, that is of our Mario, is greater than brick. So that means what you're gonna do is just increase the velocity, because the priority for the Mario is higher than that of bricks. So we'll just increase, that is with 7, that we normally do in this case, that is increasing with 7 velocity. And we'll just make this again, this Mario rect y. After this is increment in the velocity, you just have to make this, that is bottom. So this is basically saying that if you hit that basically your brick, and if you just increase that velocity, and then you should just fall back. So this basically, this statement will be just making our Mario to fall back. That means we'll make now our Mario state, that is our Mario state to be c dot fall. So after we have this fall, and if you just get confused on this statement, it is rather easy, because we're just saying that after there's increment in the velocity, that is in y, you have to just fall. So this making this bottom means you have to just make our Mario to fall. And now what you're gonna do next would be our, again we have something that is here after this state is opened. So what if we have other state, that is go here, and we'll say else. Else what if we have other state? So it should be quite here. So it is indentation problem, because okay, it is okay, it should be here. Yes, it should be here, because we're just dealing with now what if the Mario weight, or Mario basically y component, is less than that of brick rect y. What are you gonna do? Obviously we'll just make our Mario just stable, that is making this velocity of Mario to be 0. So this case is really common. So we'll just make this y velocity to be 0 now. And next thing is obviously our making this bottom, because we have to now make our Mario to walk. So in order to make our Mario to walk, we'll say first self.Mario. So get me our Mario rect bottom. So this bottom should be brick.rect.top. So this case is basically making our Mario state, that is our to walk. That means just make our Mario walk if there is basically collision, and if our Mario rect y or weight is less than that of bricks. Basically we have collision, but you cannot do with them collision with that brick. So basically here priority will be for the brick, and because the weight of our brick is greater, that means we have to make our Mario velocity 0 and just make our Mario to walk. So this will be our next implementation, that is just Mario for y brick collision. So now we have to check something, that is if you go down here, we have this check if enemy on the brick function. So let's do that. So let me say which should be implemented in the next lecture. So we'll just implement this check if enemy on the brick and these two function in the next lecture, and we'll just run our game and we'll see how this Mario games look like. So see you in the next.